Not in my backyard. That is one of the biggest complaints about nuclear energy. We say, oh, okay, my science teacher says that it's safe and it's not that bad, but I still don't really want to live next to one. I don't care if you build it in Illinois or Michigan, that's cool. We'll take their cheap electricity, but do not build one here. We don't want to face that risk, not in my backyard. And it applies to not just nuclear, but to lots of things, right? That's the argument people say, oh, windmills, they're wonderful, but I don't really want to look out my window and see one. I want them off in the distance, not in my backyard. And so nuclear's got this PR problem, right? It just people will sit there and shout, oh, it's dangerous and it's bad. And they're not actually talking from facts usually. They're just talking from reputation. When we look at how nuclear energy, nuclear power has changed over the decades, going all the way back to the 1950s, I think this is a really cool way to visualize it. You can see that the United States by far is the leader in producing nuclear power, but also remember we have one of the biggest energy budgets of any country as well. France is second, and France actually beats us in terms of percentage of their total energy use. So they get something like 85% of their energy from nuclear. You see that nuclear is cruising along, and all of a sudden we have 3 Mile Island, the first accident, and it happened in the United States. And so everybody freaked out and panicked. So they stopped building nuclear power plants. It took a long time before people forgot about 3 Mile Island, like, oh, nuclear is fine. And then we have Chernobyl. And with Chernobyl, we've got a whole bunch of deaths. There were no deaths with 3 Mile Island. And so all of a sudden, people are like, oh, we need to close the nuclear plants. And we're definitely not building any new ones. So it levels off. And then we get Fukushima, the big earthquake, Japan, tsunami. And once again, we close nuclear plants. People get scared again. It's so much based on these 3 accidents and the horrible reputation, and it impacts whether or not countries build and use it. Look at China, though. China is embracing nuclear, and that once again has everything to do with the demographic transition. They're getting away from coal and moving into, just like we did, moving into zero emission type things, wind, solar, and nuclear. Germany, and we've already talked about this a little, they are shutting down their nuclear plants. One of the big arguments against nuclear is it's like fossil fuels. We got to mine it. We got to get it out of the ground. So there's all the problems you have with tailings and mine drainage, because we have to find radioactive uranium, which can be hard to obtain. Okay, you get to the reactor though, and that's where we start that radioactive decay chain reaction. And then we've got the other big argument against nuclear. It produces waste. And what do we do with the waste? I told you yesterday that most of the uranium on Earth, 99%, is uranium-238. 235 only makes up 0.7% of the natural uranium on Earth. So it's much more rare and difficult to obtain. What we have to do is we have to make sure that our fuel pellets have at least 3% of uranium-235. That's what keeps the chain reaction going. And it's what we call fizzle. Here's one of the big safety things that I love to point out. A nuclear power plant cannot explode like a nuclear bomb. It's impossible. You will not see a big mushroom nuclear cloud if a plant was to explode. And that's because to make that kind of explosion, you need 85% of this kind of uranium. And we're only using 3. Now look at this. They line these pellets up, slide the pellets into these big long tubes, and these are called fuel rods. 1 pellet is equal to an entire ton of coal. That's amazing efficiency, right? All right, so they line these things up, drop them into control rods. Now, here's the next safety feature built into all modern nuclear plants. These fuel rods are down in this chamber, and that's where the chain reaction, and they heat up and boil the water. But we have these things called control rods. And the control rods can move up or down, and they go in between the fuel rods. When the control rods come down, they shut off the reaction. You know what happens if the power goes out at a nuclear power plant? The control rods automatically drop and start shutting down the reaction. Did that happen in Japan? Yes, it actually worked. As soon as the power went out, control rods came down. Now, they still take a while to completely stop the reaction, and so they still have to cool the water. So that's your first line of defense in a nuclear power plant. Automatic shutdown, gravity-driven control rods. If they want the reaction to go faster, they just lift the control rods more. The more they lift it, the faster the reaction goes. A moderator slows things down. And in this case, the main moderator used in nuclear plants is water. So we got the control rods, we got the fuel rods, and we're using it to heat up water inside the core in the reactor. They put a giant, like 3-inch thick steel shell around the reactor. And then they take it 2 steps further. They put a concrete shield around the entire metal reactor core. Obviously, you need pipes to get out to heat up the water. And then around that, they build a second 6-inch reinforced steel and concrete shell. That's the big domes you see around it. So we've got only 3% enriched uranium. We've got automatic control rods, and we've got 3 layers of steel and concrete to protect this core. Notice that the water that is actually radioactive never touches any other water. It's in its own closed loop. Now, in the next loop, that's where they make the steam, and it's in its own loop. And then there's even a third loop. Okay, so we got the nuclear reactor. We've got the water that's spinning the turbine, and it's in a closed loop. And then we have what's called the thermal wastewater. So to cool everything back down, they use water usually from a river or a lake. Now, there is a little bit of environmental damage here because that water is warm. And when that water goes back into the lake, there's less oxygen. Warm water does not have as much dissolved oxygen as cool. But you're going to have that with any thermal electric power plant, fossil fuels or nuclear. Remember that if I cut the left-hand side of this diagram off and all I put instead is a coal fuel furnace, it's exactly the same. Coal and nuclear make energy the exact same way. They heat up steam to spin a turbine. Nuclear waste is kept on site. We have different kinds of nuclear waste. People who go in and actually perform maintenance on the core, their gloves and their tools and their gowns, those are potentially radioactive. There may have been something that got on them. So that stuff we simply put in a barrel, put it underground, and bury it and don't worry about it. It's no different than the background radiation that comes from rocks. But that's not the stuff that people are worried about. What they're worried about are the spent fuel rods. Once the rods are no longer producing enough heat to boil water, they get replaced. But they're still radioactive. And so we put them in barrels, and then we put them deep into swimming pools that once again are built right on site with the nuclear power plant. There's been a plan to maybe start moving nuclear waste away from the facilities. Instead, we could put it all in one place, like a giant garbage dump, and then we wouldn't have to worry about it as much. Protect that big garbage dump and not care. So they actually explored this place in Nevada. It's called Yucca Mountain. That's where they did nuclear testing anyway. So there's already radiation in the soil. And so they've got this plan to bury it deep underground in this mountain. Now, they have actually built the facility already. You can see it's not too far from Las Vegas, but that's about the only thing around. They've already built this. They spent $90 billion on this already through different presidential administrations. And there is nothing stored inside of it. Not a single bit of nuclear waste. This is a lot like Anwar, right? Do we drill or not drill? And it depends on politics. Yucca Mountain's the same deal. You can see 1,000 megawatt wind power plant uses 260 square miles. 1,000 megawatt nuclear plant uses 1 square mile. Potential energy in nuclear fuel 10 million times greater than something like coal. And if you were to burn that coal, every day a coal plant releases 30,000 tons of CO2, sulfur dioxide, acid rain, nitrous oxide, smog. None of that comes out of a nuclear power plant. The only thing that comes out of a nuclear power plant is steam.